So, good morning, guys. Good afternoon. Good evening. So, I just want to do this one more question on Coulomb's law. I'm going to be fast as much as I can. 3-point charge is Q1 equals to this. 3-point charge is Q1 equals to this. Q2 is Q1. Q3 is this. Are located at this point, and this on the XY plane of a coordinate system, respectively. The distances are in meter. Calculate the total electric force F12 exerted by Q1 and Q2 and Q3. Since we are given XY plane, 3-point charges Q1, Q2, Q3. For Q1, this is the coordinate. This X, Y. So X at the origin, Y positive 0.3. So my Q1 is somewhere around here. Q2, this is the coordinate, X, Y. My X0, my Y negative 0.3. My Q2 somewhere around here. Q3, X, Y is my Y that is 0 now. My X is positive 0.4. So I'm moving now to positive 0.4X, somewhere around here. Q3. So let me join the point together. Do we get now? So now this 0.3, 0.3. You don't need to put minus here because this is already the negative axis. This 0.4. You can see. So now calculate the total electric force F12 exerted by Q1. That is the one exerted by Q1 on Q3 and the one exerted by Q2 on Q3. See, exerted by Q1 and Q2 on Q3. Q1 on Q3, Q2 on Q3. Let's find Q1 on Q3 first. Q1 on Q3. FQ1 on Q3 using the Coulomb's law. So it's going to give us KQ1 Q3 over what? R13 squared. That is the distance between Q1 and Q3. Are we together? So now we are going to get something like K9 times 10 raised power 9. Please, it's plus 9. It's not one of my video. I made a mistake and put minus 9. Please, it's plus 9. Take note of that. Take note of that. Times, what's our Q1? Q1 is 2 microcoulomb. 2 times 10 raised power minus 6 micro 3 raised power minus 6. That's our Q1. On Q3, sorry, this on Q3. So what's our Q3? 4 times 4 times 10 raised power minus 6 over, what's the distance between Q1 and Q3? This is the distance. Since you have 0.3 here, you have 0.4 here, use Pythagoras to find the hypotenuse. Hypotenuse square equals to opposite square plus adjacent square. You will get 0.5 here. So this one is 5 times 10 raised power minus 1. That's 0.5 square. Now, if you calculate everything, you are going to get something like up. So this guy, I'm going to get 72 over 25 times 10 raised power minus 3 times 10 raised power 4. So it's going to give me 2.88 times 10 raised power 1, which is something as 28.8 Newton. Yeah. I think that's correct. So 28.8 Newton, that's the force here. 28.8 Newton. You can check through this calculation. Understand the step. Think is 0.288. Well, 28.8 Newton. Let's move on. So if you want to find Q2 on Q3 too, you are going to use KQ2 Q3 over R1 R23 square, which is something as 9 times 10 raised power 9 times, what's our Q2? We are told that Q2 equals to Q1. 2 times 10 raised power minus 6 times, what's Q3? 4 times 10 raised power minus 6. Well, the distance is still 0.5 square. Oh, sorry. This times 10 raised power minus 1. Sorry, yeah. So this guy is going to give us 0.288 Newton. 0.288 Newton. Are we together? So yeah, that's that for that. So since we still have this one too, we still give us 0.288 Newton. So here we also have 0.288 Newton. Am I communicating? So whenever you have XY coordinate in this pattern, so you are going to resolve to both horizontal and vertical. You can see that this Q1 is positive, Q3 is also positive. So the force exerted by Q1 or Q3 is a force of repulsion. Q1 is pushing Q3 downward. Are we together? You can see. So to the positive, to the x-axis, it will be pushing it towards this side. To the y-axis, it will be pushing it downward. You can see this arrow. Convert this arrow to x and y axis. This, because like play, Q3 will be going like this. It will also be coming downward. You can see this slant height means it's going this way, it's also going this way. So that's why we are resolving to both horizontal and vertical. But for the vertical is downward, for the horizontal is rightward. So same thing with this. It's also a force of repulsion because Q2 is also positive, Q3 is positive. So this guy will be repulsing Q3. So for the x-axis, it will also be coming to the rightward. For the y-axis, it will be going upward. So now, let me bring those two out. For the one on the upward, for the one, this one here, I'm bringing it out. That's 0.288. All together. So I need the angle here. The angle at which this slant height makes to the vertical. So let me bring out the second one. 0.288. So I also need the the angle. Yeah, I need the angle here. The angle here. Not this one. You can see this one was not there before. We just put it. So it's the angle here we need. So that's that for that. Now, how do we get this angle? No, whatever angle we get here is still going to be the same thing because the lengths are the same. This length, they are the same thing. 0.4, 0.4, 0.3, 0.3. So let's just find one. Since we have 0.3 here and we have 0.4 here, this 0.4 is equal to, is parallel to this line. So this place is also 0.4. So to find our angle theta here, this opposite, this adjacent. So using tan theta. So theta will give us tan inverse of what? Opposite over adjacent. 0.4 divided by 0.3. Are we together? That's tan theta equals to opposite over adjacent. Theta gives us tan inverse of 0.4 divided by 0.3. So that's 0.4 divided by 0.3. Not tan inverse, I'm sorry, arctan. It's not. Is that tan inverse? I think it's same thing as tan inverse. Don't mind me. Equals to, yeah, shift tan answer 1.33. Shift tan 1.333. So my theta equals to 53.1 degree. So here also I will have 53.1 degree. Are we together? Are we together? We are resolving to both horizontal and vertical because the force is moving like this. So going somehow like this and somehow like this. So we want to know amount of this 0.288 Newton that is going like this and amount of it that is coming like this. So now let's deal with the one at the top, then we come to the one at the down. Now, since we already have this 0.288, we have our theta. So we don't need this distance anymore. We just use it to find our angle. So now let's find the amount of this force that belongs to this x-axis and the amount that is coming down to this y-axis. So since you have your hypotenuse, this x-axis, your fx, force on the x-axis, and this your fy. Your fx, that's your fy. Just come and just follow it steadily. So now your fx is opposite and you have an hypotenuse. So to find your fx opposite, while you have an hypotenuse, you are using sine. So sine theta 53.1 equals to opposite fx over hypotenuse 0.288. So if you cross multiply your fx1, let's name the one upward as 1, the one downward as 2. Your fx1 will give us what? 0.288 sine 53.1 I. Anything x-axis means I. Now your Fy1 equals to, now our Fy is adjacent to the angle. So when you have adjacent and hypotenuse, you are using car. So this guy will change to cos for the Fy. So here you have 0.288 cos 53.1 J for y-axis J. But you see that y is coming downward. See, it's coming downward. So it's going to be negative. It's coming to the negative y. Now for the Fx2, let's pick the one downward now. The one downward, Fx2. This your x is parallel to this line. So this your Fx and this your Fy. Your Fx is also opposite to the angle, and you have your this thing. Let me draw it to make it clean. Sorry. Let me draw it clean for those who doesn't understand the first one so that they can understand this one. 0.288 Newton. And I have my angle 53.1 degree, my Fx and my Fy. So to find this Fx for the second one at the down, this y is going upward because Q2 is pushing Q3, y upward, x like this. For this one, Q1 is pushing Q3 downward, this, we've done that. Now for the other one, your Fx is opposite. So for you to find when you have opposite and hypotenuse, you are using sin theta equals to Fx over 0.288. Now, if you cross multiply for your Fx2, you have 0.288 sine 53.1 I. X is I-axis. It's going to be plus because it's going to the positive x-axis. Are we together? So for the y adjacent, your Fy2 equals to 0.288 cos, because it's adjacent, cos 53.1 J. Now it's going to be positive because the y is going upward to the positive x-axis. Now let's add everything together. Now is 0.288 sine 53.1. So our Fx1 equals to 0.2323 I. Fx2, if you do this one to Fx2, we get 0.23 I. Now Fy1, if you do this one, 0.288 cos 53.1 is going to give us minus, because that one is coming to the negative x-axis, minus 0.173 J. Fy2 will give us 0.7173 J. Now add all the I together and add all the y together. If you add the y together, it will cancel out, minus and plus. So here you have 0J plus, add the x together, you have 0.46 I plus 0J. So that's the vector. The force exerted by Q1 and Q2 on Q3. That's it. To get the magnitude now, we're going to use root 0.46 square plus 0 square, which is what? 0.46 Newton. So that's the force exerted by Q1 and Q2, the magnitude. But if you still want to get the vector in another pattern, that is the magnitude and the direction, this is the vector. But if you want to convert it to something like this with a direction, this one now, we have the direction, I and j is 0. It's only I here because the j is 0. 0.46 in the I direction, the x direction. But if you don't want to put I, if you want to do it like this, this is the magnitude, then what's the direction? To the positive x direction. To the positive x direction. To the positive x direction. So that's that for that. You can just go back through the video and go to the video and go back through. Now let's talk about electrodynamics. Now electrodynamics. They deals with the study of electric charges in motion and the resulting electric field. So dynamics in motion. So where is the question? Let me just move straight to the question. So we have a nearly uniform electric field is produced in a small gap between two parallel conducting plates when the terminals Ds of a battery are connected to them. So we are given the upper plate. If you read the question very well, we are given the upper plate to be negative and the lower plate to be positive. The field will be going out of the positive. So my field will be like this. This is the direction of my field. We connect it to a battery. Let's say this is the battery. Don't mind the way my battery is. Let's say this is the positive terminal, but this is the negative. So the negative plate to the negative terminal of the battery, the positive plate to the positive terminal of the battery. Are we together? So we now have an electron that is coming from the upper plate according to the question. No electron has negative charge. It's coming to the upper plate to the downward plane. Are we together? That means the electron is moving against the field because the field is upward. The electron is coming downward. That's another thing they can ask you there. Are we together? So that's one thing. So we have our E. We have been given E to be 1 times 10 raised to power 4 Newton per charge. We have been given distance x. Because we are given the gap between the two plates. The gap is 1 centimeter. The gap. So that's the distance between the two plates to the distance that this electron will cover, because that's the gap between the plate, 1 centimeter, which is equivalent to 0.01 meter. Convert it to meter by dividing it by 100, 0.01 meter. So now we have to calculate the acceleration of an electron released from the upper plate. So our A equals to unknown. You know that F equals to ma and F equals to QE. We all know that. QE. Don't forget, that means ma equals to QE. Want to find the acceleration of the electron, that means A equals to QE over m. But note, this m is the mass of electron. So what's our Q? The charge of an electron. Is the electron that is coming. So we use the charge, 1.6 times 10 raised power minus 19. Are we together? 1.6 times 10 raised power minus 19. What's our E? We have been given E in the question. 1 times 10 raised power 4. 1 times 10 raised power 4. Sorry. 1.6 times 10 raised power minus 19 times 1 times 10 raised power 4. What's the mass of an electron? 9.1. We are not given, but it's constant. 9.1 times 10 raised power minus 31. So if you do it, you are going to get 1.76 times 10 raised power 16 meter per second square. That's our acceleration. Are we together? Now the other question says is speed. Speed. Can use v square equals to u square plus 2as. The speed of the electron when it's coming down to the down plane. So we know the electron was at rest before it starts moving. So your u is going to be 0. So that means you have v square equals to 2as. Then your v will give you root 2as. Are we together? So we have 2. What's our a? 1.76 times 10 raised power 16. What's our s? The s is the gap between the plate, which is the same thing as distance the electron will cover. This is 0.01 meter. That's 10 raised power minus 2 meter. So here you are going to get 1.76 times 2 times 1.76 equals to, so times 10 raised to power 14. So should it be this? I think this one should be 1.6 divided by 9.1. 0.716. Sorry, this guy should be 15. Yeah, thank you. Should be 15. So at the end of the day, I will have, this is going to give me root 2 times 1.76, root 3.52 times 10 raised power 13. So my velocity is equal to 5.9 times 10 raised to power 1, 2, 3 times 10 raised to power 6 meter per second. That's the answer. Now the next one says its kinetic energy. No Ke equals to 1 over 2 me, mass of electron, v square. Are we together? Which is 1 over 2 times 9.1 times 10 raised to power minus 31 times, what's my v? This is my v, yeah, v square. My v square, if you square this, you will get this guy back. Are we together? If you square this, you get it back. Yeah. So this is going to give me 3.52 times 10 raised to power 13. That's my v square. You can write this and square it. You can write v there and square it. If you square this v, you will get this guy back. So times 9.1 times 10 raised to power minus 31 divided by 2. So this gives my kinetic energy is equal to 1.6 times 10 raised to power minus 17 joule. Are we together? So that's the kinetic energy. It's very simple. Just take note of what we are doing. Now the time taken to move from upper to lower plate. That V equals to U plus what? AT. Since it's starting from rest. U is 0, V equals to AT. Then T, it gives us V over A, which is what? 5.9 times 10 raised to power 6 over, what's our acceleration? Our acceleration is 1.76 times 10 raised to power 15. Are we together? So we have 5.9 divided by 1.76. So that gives us is equal to 3.35 times 10 raised to power 6 minus 15 times 10 raised to power minus 9 seconds. Yeah, that's the time taken. Very short period of time. Right? Because the guy probably is moving with speed of light. Very short time. Wow. So that's that for that. So I'm confirming if those answers are correct. I think they are correct. Now let's move to electric field. In my last video, I've done something on this. So this is just like another set of questions. So I'm not going back to whatsoever. Now, a dipole constantly charges Q1, this and this, because which are these apart is illustrated with 3 points A, B, and C below. Calculate the electric field of Q1, the electric field of Q1, of Q2, and the total electric field. How do we calculate the electric field of and the total electric field at point A? That means the electric field of Q1 at point A, of Q2 at point A, total electric field at point A, electric field of Q1 at point B, Q2 at point B, total at point B, electric field of Q1 at point C, Q2 at point C, total at point C. That's the question. Now I'm moving to total at point C. That's the main issue, but let me just give us a few things. Now the electric field at point A, electric field of Q1 at point A is going to give us this Q1, this point A. The distance between point A and Q1 is 6 centimeter. Convert it to meter. That is 0.06 meter. That's R equals to, and you know electric field strength or intensity equals to force, equals to K rather, 9 times 10 raised to power 9. This E equals to KQ over R square. 9 times 10 raised to power 9. What's our Q? We are given that our Q equals to 12. Please take note, dipole, for a dipole, both Q must be the same as far as magnitude is concerned. They must have the same magnitude, 12, 12. If they put 9 here, it's no longer a dipole. For a dipole, they must have the same magnitude, but opposite sign. So take note of that. So whenever I say a question that you're having 12 and you're having 9 and they call it a dipole, just go to the option. Once you are done reading the question, go to the option and pick none of the above. So it's not a dipole. For a dipole, they must have the same charge, but just the sign will be different. If they have the same sign too, that's not a dipole. Sure you get. So a dipole is a pair of point charges with equal magnitude but opposite sign. That's the definition. Please take note of that. So what's our Q? Our Q is what? Times 12 times 10 raised to power 9 minus 9. That's nanocoulomb over R square. 6 times 10 raised to power minus 2 square. This is 6 times 10 raised to power minus 2. This 10 raised power minus 9 cancel 10 raised power 9. So we have 9 times 12 left. 9 times 12. So here we have is equal to 108 divided by 6 squared 36 times 10 raised power minus 4. So divided by 36. So here we have 3 times 10 raised power 4 Newton per C. That's the electric field at point A. Electric field of Q1 at point A. Electric field of Q2 at point A. You can find that Q2 at point A, you just use the distance of 4 altogether. Electric field of Q1 at point B. This is Q1, this is point B. You still follow the same process, distance of 4. Q2 at point B. Because from Q2 to point B, you have 4, 6, 4. You have 14 centimeters. So the distance you are using is 14 centimeters. So where I'm going to now, total electric field, the total electric field at point A. Then you are going to find Q1 at point A, Q2 at point A, and add them together. See this question, see the total electric field, which is same as the electric field of the dipole at point A, which means Q1 at point A plus the Q2 at point A. Now, I'll find the Q1 at point A. I skip all this at point A. I'm going to total. That's my focus. So Q2 at point A, at point A, at point A, give me E equals to 9 times 10 raised power 9. What's my Q2? 12 times 10 raised power minus 9. 12 times 10 raised power minus 9. Over what's the distance between Q2 to point A is 4 times 10 raised power minus 2 meter r square. So this guy give us 108 divided by 16. So this is now 6.75 times 10 raised power 4 Newton per C. Now, Q1 at point A is this, Q2 at point A is this, Q1 at point A is this, Q2 at point A is this. Now, what's the total at point A? Now, Q1 is positive. The field will be, moving away. Are we together? Q2 is negative. The field will be moving towards Q2. Because this is positive, field will be moving away from positive charge. So away from Q1. This is negative. The field of Q1 at point A will be moving towards, of Q2 rather, will be moving towards Q2. To be coming into Q2. This one will be going from Q1. Hadn't BD is positive, the field will be faced like this. Or negative to be coming. That means both electric field, they are still going to the same direction, x direction. So the total, you are going to add these two together because they are still going to the same direction. So the total electric field at point A will be Q2 at point A plus Q1 at point A, 6.75 times 10 raised power 4 plus 3 times 10 raised power 4. Then you get 9.75 times 10 raised power 4 Newton per C. This is the total electric field at point A. For point B, at point B, now the electric field of Q1 at point B, Q1 at point B, at point B equals to K is going to give us 9 times 10 raised power 9. What's our Q1? 12 times 10 raised power minus 9. At point B, Q1 to point B, that's 4 centimeters. Convert it to a meter. You're going to have 4 times 10 raised power minus 2 square. So this is going to give us 6.75 times 10 raised power 4 Newton per C. Now for Q2 at point B, Q2 at point B, going to give us 9 times 10 raised power 9 times 12 times 10 raised power minus 9 over. Now from Q2 to point B, we have distance of 14 centimeter. Same thing as 14 times 10 raised power minus 2 meter square. So it's going to give us 14 square. One 196. So we're having 108 divided by 196. This guy is going to give us 5.5 times 10 raised power 3 Newton per C. Now, total electric field of Q1 and Q2 at point B. At point B will be what? Now, let's see whether we are going to add this time or subtract. Now, Q2 at point B, Q2, this positive, so it will be going out. It will be going out. The other time is at point A. This Q2 now will be going out. Q1 rather. But for Q2, Q2 is negative. So at point B, for Q2, it will be coming in. It will be in this direction. It will be coming in. Let me explain better. This is it. Q1 will be going out. Q1 will be going out. But Q2, because Q2 is negative, it will be coming in. Are we together? It will be coming in towards Q2. So going out, coming in, that's opposite direction. So in this case, the total electric field at point B will be 6.75 times 10 raised power 4 minus, because they are opposite direction, minus 5.5 times 10 raised power 3. I'm going to get 6.2 times 10 raised power 4 Newton per C. So that's that. Now, but the electric field at point C, let's calculate the electric field at point C. Electric field of Q1 or even Q2 because they are going to, okay, don't worry, of Q1 at point C. At point C, it's going to give you 9 times 10 raised power 9 times 12 times 10 raised power minus 9 over distance between Q1 and point C equals to 13 centimeter. That's 13 times 10 raised power minus 2 meter square. So if we do this, 108 divided by 169. So this is going to give us 6.4 times 10 raised power 3 Newton per C. Newton per C. To the positive y direction, because it's pushing it, is going to be outward rather, this field, not force. So to the positive x direction, please take note. Positive y is going up. Positive y and positive x is going up, positive y or positive x direction. Electric field of Q1 at point C. Now, but of Q2 at point C, this one will be coming down because it's negative. The field will be coming down. We still get the same value for it because the charge are the same while the distance are still the same. But this time, the field will be coming to negative y because the field is downward. Here, the field is upward, it's positive. Positive y or positive x. If you resolve this field to y is like this, result to x is like this. But this one is coming down, negative y and positive x. This is just the field of Q1 at point C. This is the field. You don't need to put whether positive or whatsoever. I'm just explaining because I'm going to that aspect now. This is the electric field of Q1 at point C. That's that for that. Or probably, yeah.